Our next presentation is from Jagoteq. It's really, really cool, as you're about to find out, using laser light shooting down glass.
Fiber optic.
Fiber optic.
Yeah.
Eric Egley is going to tell us all about it. First, he's going to show us a little video.
Give you a real quick video here just to give you an idea. Use cases and... All right. Thank you for sitting through that. And thank you, DCS, for allowing us the opportunity to show our new product here. So what we're dealing with is fiber optics, all laser driven. There's a couple advantages over LED ribbon that we have. One of the biggest advantages, number one, we can go a good 10 meters with one emitter, and we can go 100 feet or 30 meters with two emitters. And the way you cut it or cut it to length is real simple. Done. I mean, we're done. And then you just connect it to your adapter and you're all set. I mean, it is a very quick and efficient way to apply this technology. And that's one of the beauties of it. You can probably cut down your workflow by probably 50 to 75%. The other part of this is reusable. The fiber that I have in the booth, we've used it probably 24 times in different demos, different events, different trade shows, and it's still just like new. So instead of ripping it up and throwing it away, you can reuse it multiple times. So you're saving on that end as well. And if you get to the point where it's no longer usable, it's 100% recyclable. And you can reuse it pretty much any length. So if you cut it down to 15 feet, you can still use that piece, all the way down to 12 inches. And let me just explain the 12-inch thing. Okay, we're dealing with high power lasers, right? So safety is of the utmost. I mean, we don't want anybody getting hurt on set. We don't want any users getting hurt, okay? So say this all goes through FDA. It's all FDA regulated. It's all government. We have to be certified. The machines have to be certified. So safety is of the utmost importance, whether it's our large unit or our small one. Some of the safeties that we have built in, there's a safety door here, which is IR driven. So if there is no transfer fiber here, the machine will not start, period. Okay, we don't want any laser emissions out that laser port. On the other side of this, what we do is from the transfer fiber to the adapter, this adapter, if you pull this out, no laser emission out of that port either. Okay, so we want to make sure that there's no raw laser getting to anybody. One of the really nice features as well is we can go from the laser port. This is a transfer fiber. This is pure silica fiber, okay, stainless steel jacketed with PVC. So this we can go anywhere from 30 feet to 200 feet with no line loss. So you can put this in a control room, you can leave it on the truck, whatever. run your transfer fiber to set, and that's where the fiber actually starts being illuminated.
Now,
So-
as long as you keep this safe and dry,
Yes.
this can be totally submersible, right?
100% waterproof. I mean, it's a solid core. This is a solid core, flexible acrylic. So you can submerge it in pretty much anything. I wouldn't suggest gasoline, but you know, I mean, unless you need special effects. But yeah, totally submersible. You don't really have to, I mean, I had one of the images on there. I just put the fiber on a reflector board, dropped it in the pool, and used it for video clips.
You could
So,
write your name with this and
yeah, that's
hide it in the set.
yeah. We have used it as a neon replacement. This is the 8 millimeter. The 6 millimeter works a little bit better, but each one has a bend radius. Okay, this one's right about there, and you can see you start getting a little feedback. But yeah, you could definitely use it as neon replacement.
And you just, this is the end of it, you just cut it and as to
Yep.
length and put a cap on it.
Correct.
And then feed it,
So I'll explain
feed the
that.
laser and that way.
So, yeah, end cap here, okay? Like I said, 12 inches is our minimum length, okay? This is safe, okay? It's not gonna blind me or anything else. Because the attenuation or the reflectivity and refraction within the fiber itself, you don't have to worry about the laser radiation. But this,
That's sort of an interesting effect, the light coming out of the end of it. It's
yeah.
okay to use that?
Well, we won't talk about that.
Okay, never mind.
Yeah, because what we're going to end up doing is actually making fixtures for the ends of these.
Oh.
Because we do have a black jacketed PMMA fiber that we can run, you know, a good 30 to 50 feet. Put a fixture on the end, yeah, and you're good to go. Because you can fit those in places you can't fit anywhere else, you know, because it is a fiber. So as far as the box itself, we have DMX in and out. We have an Ethernet port for data. 2 UI screens. One is for just status. Okay, it tells you if the laser's on, if there's any heat issues. The other one is for dynamic changes that you can make, whether it's your DMX channels, color, obviously, and then any configuration. There is safeties on the inside as well. And so if there's any heat buildup, fans will automatically start cycling upward until that heat buildup is down. If it gets to a critical point, the whole machine shuts off. Again, safety is very important to everything that we do.
You mentioned needing to be certified. Do you need an operator with this, or can you rent this and
You
go
can
to
rent
town?
it. So there's, this is going to be classed as a 3R laser, okay, which means what we would like you to do is obviously review the safety data, okay? But as a system, it's going to be 3R and totally safe, okay? I just did a safety video so that everybody knows exactly what is expected of you as an operator. And it's important to keep everything clean. I mean, we're talking about optics. Everything on here is optics. Okay, so everything needs to stay clean until the point, you know, you hook it up. At that point, everything is contained. So after that, you're fine, but everything needs to stay clean up to that point. We also have our little unit here. This is the LF30. And, you know, this is actually a glass fiber. This is 1 millimeter. So we're going to have fibers that go from 1 millimeter, 3 millimeter, 6, 8, and 12 millimeters. So depending upon the use, you have a wide variety of fibers that you can use. This one in particular, you can go up to 75 feet with one emitter, and it's very little line loss. If you put a second one on the other side, obviously, you get twice the amount of light. So, and you can do some really cool color blending when you have one on each end, because you can have the color loops going or different colors blending within that fiber itself. So again, no electricity goes through this fiber at all, just light.
Speaking of color, is it like, what color space is it? You can probably get some really saturated colors?
Well, good point. So lasers are very specific. These are about, oh God, 30 to, probably about 30% more saturated than LEDs, okay? Because LEDs are a broad spectrum, regardless of what color you're dealing with. It's more of a broad spectrum light, the phosphors are. With LEDs, it's a very specific nanometer within about 4 nanometers. So if we look at CRI, we're not going to get CRI. It's just physically impossible to get CRI with lasers. It's not going to happen. Because what we have is on red, it's a spike here, green spike, and blue spike. There's no broad spectrum whatsoever. We can, however, dial in Kelvin, okay? So we can get a nice Kelvin out of it. We just simply cannot get CRI.
Can you run it through the spectrum that you can get?
Yeah, absolutely.
Just so everybody gets an idea.
So we get a little bit of red. I'm going to get rid of the blue
Very
here.
saturated.
Oh, hold on. Let me get rid of that blue. And I'm going to run it up quite a bit here just so you can see how saturated it is. This is hard doing this from up on top here. Okay, so I'm going to run the red all the way up now.
Oh, yeah.
I mean, if you see that, super, super saturated. And if you match that to an LED, the LEDs actually look almost pinky orange.
Devil lighting.
Yeah. Whoop. Let me go the other direction here. Same with the green. Green is a really nice, highly saturated. It's a primary green.
Goblin lighting. Goblin lighting.
And then, of course, our blue.
That's my favorite color.
Yeah, there you go. There you go. Awesome.
I'm sorry I've been interrupting you, but
No, I
I'm
love
really
it.
excited about this technology. It's very cool.
Well, I'm glad. Hopefully everybody else is too. Yeah, no, it's we're excited to get it out in the marketplace. We're not in full production yet. We're looking at probably end of March as far as full production. But you know, if you have a production that you're working on and you think this might work well for it, give us a call because we want to get it in hands of users. Okay, and we want to see what you can do with it because, you know, it's all about creativity and the minds out there and how they actually take this and get it into, you know, reality.
Will Jagoteq rent these, or is it for sale to the
So
rental
yeah,
companies, or
the
both?
big units will be rented, and right now one of our distributors will be RST, Visions in Color. The small unit we're gonna probably sell right off the bat. So yeah, and of course all the fiber is expendables. The transfer fiber, that'll be part of the rental, unless you want like a 300-foot piece of transfer fiber, then that's sort of a special order type thing. To be honest, to get, you know, that kind of length, it gets a little pricey because that is pure silica and it costs money to get that made. But it's possible. You know, we could probably go 500 foot with no problem. So.
You ready to take some questions if they
Absolutely.
have 'em? What kind of wireless control?
Yeah, so the wireless, we got ArtNet and SACN. That's a protocol, okay, and then we will have wireless built into it. It's not going to be implemented right away. That's why I'm using, you know, one of the antennas right now. So, but yeah, so that will be built into it at a certain point. We're just sort of concentrating on getting it all out there right now. But yeah, at a certain point we'll get there with the Wi-Fi. So the effects that you can do with lasers are the same as traditional LEDs. Okay, it's not pixel mapped, obviously, but you can flash it, you can fade it. There's absolutely 100% flicker free, no matter what shutter speed you're using. So you don't have to worry about that. It's you know, a little different. How it's energized is a lot different than LED phosphors. So you don't have to worry about flicker. It's, you know.
We don't like flicker.
We don't.
One more question here.
It is DMX compatible. Yeah, we got DMX in and out on the front. Plus we'll have a, yeah,
How many channels
4.
is the question?
Yep.
Why does it
Yeah.
look
Yep.
so saturated to the eye compared to what we see on the monitor. I think it's because it's bright, and we're just overdriving the
Yeah,
cameras, which
that's what it is,
starts
yeah.
to go white. How far can it go?
Oh,
Let's-
okay, if you're looking at, because we're projecting it through a PMMA fiber, you do get attenuation or fall off. Yeah, I mean, there will be a certain amount of fall off, but it's in small percentages. It's almost indiscernible. You know, and what we're looking at in the future, and I'll tell you a little bit about future, things that we're going to do is we'll have an NFC chip right at the end of the transfer fiber. So what that'll do is it'll talk to our laser engine and say, okay, I got 200 foot of transfer fiber. That might be, let's say, 5% reduction in light. So it'll actually boost the lasers to make up for that 5%. We want to make sure everything stays, consistent.
I think we're going to have to wrap it up. Thank you so much, Eric.
All right.